an introduction to heat and to calorimetry. This is the first thing we're going through in our thermochemistry unit. This is one of my favorite things to talk about. I love heat. I love calorimetry. I just think it's good, fun math, which I know some of you hear that math word and get nervous, but we'll get through this. So thermochemistry is the study of heat changes that occur within chemical reactions and phase changes. It gives us a lot of information about how much energy is in a chemical reaction and how energy is transferred between the system and the surroundings. And so the energy of the universe is always talked about as divided between the system that we're studying and the surroundings. So you can think of the system as this portion here, the stuff that's happening in the flask, in the beaker, what we're sticking the thermometer into, and then every other part of the universe is the surroundings. So if there's energy being transferred, it's being transferred from the system to the surroundings, or from the surroundings into the system. So you just need to know what I'm talking about when I say system and surroundings. Calorimetry is how we're going to measure this heat flow or this energy flow. A calorimeter is used to measure the heat flow. And so what a calorimeter is this vessel that has this inner vessel, which is where your reaction happens. And then you have some sort of insulating outer vessel. The really good ones have a vacuum, kind of like your Hydro flasks or your Yeti flasks. Those would actually make, I think, pretty good calorimeters, but they're spendy. Or the ones that I have in the chem storeroom are just insulated with some foam. And then you have a lid to go over top, and then you have a stirring stick, and you have some way of measuring temperature, so either a thermometer or a temperature probe that connects to some digital interface. Also, quite often what science teachers will use are what are called coffee cup calorimeters, and so you just have two styrofoam cups stacked in each other. And those actually work pretty well for calorimeters because you don't have heat transferring into the system or out of the system as much, just because those two layers of styrofoam are pretty good. So how we measure heat absorbance is with this formula. As always, I'm not going to have you memorize this formula. It's always going to be displayed in some way for you. The amount of heat a substance absorbs can be calculated with this Q equals mc delta T. Q is how we represent heat. We don't use an H for heat because we use H for something else in thermochemistry. So Q is what we use for heat, and it's measured in joules. M is mass. That's going to be measured in grams. If we're working with a solution, which we will be, okay, it has to be the total mass of the solution. So you have to add up the solvent and the solute masses. Okay, C is specific heat. That's measured in joules per gram degrees Celsius. You will always be given it. And delta T is the change in temperature. So as you might imagine, we're going to need to measure temperature in degrees Celsius, so that way we can use the specific heat that's measured using degrees Celsius. Okay, for water, your specific heat is 4.184 joules per gram degrees Celsius. Okay, you're not going to need to memorize that, but it's a really, really common one that we're going to use. So you may eventually accidentally memorize it. So our practice, how much heat is needed to warm 250 grams of water, which is about 1 cup, from 22 degrees Celsius to 98 degrees Celsius. So what I'm going to start doing, I'm going to write down what I know, and what I don't know. Okay? It's asking me for heat, which is Q, so I don't know that. Grams of water. I know that mass is measured in grams, so I have 250 grams. And then I also know my specific heat. I just said it. Water specific heat is 4.184 joules per gram degrees Celsius. And then delta T, that's change in temperature. Okay, so that means we need to take our beginning temperature and our final temperature. So change in, so anything that's delta, we always take final minus initial. So we're going to take 98 minus 22. Okay, 98 minus 22. Hopefully we can do that in our heads. That should be 76, right? So then we're just going to plug this into our equation, which is Q equals MC delta T. Okay, so we have 250, excuse me, off by an order of magnitude there, times 4.184 times 76. Okay, if those all multiply together, our label is going to be in joules. So 250 times 4.184 times 76, that gets you a total of 79,000. Yep. And with sig figs, it's just going to be 79,000 joules because I only have 2 sig figs here, 2 sig figs here. Okay, 79,000 joules or 79 kilojoules. If you write in a K, you can knock off 3 zeros from the end. Makes it a little bit neater. Now, heat of a reaction. So quite often what we're doing is not necessarily just adding something or just heating one thing up. What we're actually doing is adding a mass of some solid to water or another solvent and measuring either how much energy that reaction takes in or that solvation reaction puts out. So since this is a mass of a solution, we need to add up the mass of the solvent and the solute. And then we're going to use the specific heat of that solvent. So since water is the universal solvent, it's most often that we use the specific heat of water. If we're going to use the specific heat of something else, you'll be given it. So if you're dissolving something in ethanol, I'll definitely give you that change. And so then your heat of your solution is what you find when you plug these things in. And then the heat of the reaction is actually the opposite, the additive opposite of that. So what we have is 22 grams of sodium chloride are dissolved in 200 grams of water. During the reaction, the temperature changes by 0.32 degrees Celsius. Calculate the heat of the reaction. So once again, I'm going to write down what I know and what I don't know. So I don't know Q solution. Which is equal to negative Q reaction. Sorry about the bell. Okay. Which is a big old question mark. Okay. But what we do know, okay, mass of our solution. Okay, we're going to take 200 plus 22, so that's 222 grams. And then we know our delta T. Okay, it said it changed by 0.32. And then our C, we're going to use water. 4.184. So then we're just going to plug this in. Our Q solution is what we're going to end up finding first. So that's going to be the 222 times 4.184 times 0.32 and that gives us 297 joules. Okay, Q solution. Now what it wanted is the heat of the reaction, which is Q reaction. And that is just equal to the additive opposite, so we just do negative 297 joules. The most common mistake that I see is that people forget to make this negative, and so they give me Q solution when I'm asking for the heat of the reaction. So definitely check yourself, make sure you're giving the correct thing that is being asked for in the problem. Okay, that is it for this notes video for today. You have an assignment. Once again, you can check your work with the key that is up front. Thank you.